All right, so question one, we split up the constant buffers into two different structures. So up here we have our camera data, the view and projection matrices, and then we also have our world matrices down here specifically for the object. We do that in the HLSL file, and also in our draw scene, we have the camera data established first, and then the world matrix data right below that. And then going into question two, we're using the model class to generate preconditioned objects. In this case, we have a pyramid here. So, here's the vertices and the indices code that I have set up for that. And there it is declared right there. And then question three, we're just generating three different objects on screen. So if we go into our initializer function, we have three different models for the three different objects declared there. And then we also have the world matrices are initialized here as well. Some of them have different scale and translation to move the objects around and make them different in size. And then in our draw scene, again, after we take care of our camera data for each of these objects, we input its world matrix, and then we also give each of them a color. And then we put those, and then we render each of those objects individually. And then question four, we generate four different objects, but the key difference here is the two different shaders at the same time, our selected color and our rainbow. So if we go into our initializer function, here we go. So we create the two different vertex shader here in the initializer. So the first one is pulled from the color selected file. So that's the one where we get to choose our specific color. And then the other one here is our simple color file. So that's where we get the rainbow effect. And then now normally we would be declaring the constant buffers here in the initializer as well to pass in the vertex shader right away. But since we have more than one vertex shader on the screen at once, we actually go down into our draw scene to implement them at different times and change up the order of the render pipeline. So we have our color selected shader first with those constant buffers. We generate the first two objects here. We choose those colors. And then after that, we just simply go ahead and switch over to our other vertex shader, our simple color, and then generate the two cubes with the rainbow effect. And then also in this iteration, even though we have four different objects, we actually just have two different models to handle them. And that's just simply because we only have two different shapes to handle. We have two pyramids and two boxes. So the reason you would you'd want fewer models is, imagine if you had to put in like 100 cubes on the screen. Obviously, it's not going to be very effective to make 100 different instances of the same exact model. 100 different models just for this one instance of the cube. I mean, you can use matrices to take that one instance and make it smaller or make it bigger or move it around. There are much more effective ways to take care of that. And then I also have a shader class here that isn't implemented, but potentially shows off how it can make DX more streamlined. So we have a specialized constructor here with a few arguments. The most important one is this PM, which is similar to the model class. We have an enum structure that has a couple options that the user inputs. Depending on what they input for that, we get a specific file name of where we want to compile our vertex shader. We compile it from the file here. Then we create the vertex shader and place it in the reference. We load the shader, and then this function here the user uses to load that shader in whenever they want. They can use it in the initializer or draw scene, wherever they want. And then last, question 5 is all about generating the sphere with the model class. So once again, here we go. So it's generated here with 6 vertical and horizontal lines. Basically, we're just using sine and cosine to change the position of the vertices. And there's also a formula here to generate the indices and the triangles that make that up. And let me also quickly, just to show that this is dynamic, if I change the vertical and horizontal line number, we should be getting a much smoother sphere. There we go.